Okay, class. Can we continue with our lecture, with our sharing? All right. Today, now I'm going to show you how to understand confusion matrix and what is iris dataset. Which one? Iris dataset. Yeah. Yeah. What is iris dataset? Yeah. As I explained just now, iris dataset. Yeah. On slide number 46. Yeah. What is an iris dataset? And how to do classification in MATLAB. All right. So iris dataset, the data for this paper from Fisher, I include on the folder Fisher iris.slx. Yeah? You can open this file. Okay. Okay. All right. Okay. There are 3 versions. Sorry. Are you ready, everyone? For number 1, if you are ready. Can you hear me? All right. If you good. If you Google, you search for iris dataset, you can easily find a lot number of website and papers citing this dataset for classification. Actually, they pick 3 species: Setosa, versicolor, and virginica. Yeah. These are the picture. Yeah. These are the picture of these 3 species, and they measure the CPAL. This is what we call this part. Yeah. This part. This is what we call CPAL. Yeah. Okay. CPAL. This is what we call PITAL. Okay. So they measure from this flower, they measure the length and the width. The length and the width. So that's why they managed to get 4 variables. Yeah. Sepal length, sepal width, petal length, petal width. Okay. They purposely pick 50 sample for each species. Yeah, 50. So if you go through the data, 50, yeah, 50 from 1 to 51, and from 52 to 101 versicolor, and finally from 102 to 151 is virginica. Okay, so it is 3 class. Yeah, so we can call this class 1 Setosa, we can call versicolor class 2, we can call virginica class 3, or A, B, C. So for me, I commonly put 1, 2, 3. Sometimes people put 0 and 1. Okay, I show you one example of data set. This one, chemical ID, and this is mutagenicity or activity of data set in QSR. This is CS number. So they put mutagen class 1 and non-mutagen 0 for activity. Okay, this is a 2-class system. Normally in the study of chemical activity, we put 2 classes, 1 and 2, or 0 and 1. Okay, you have your own choice. There are risks of putting this number. It is not in our discussion. Okay. Now, look at the Fisher iris. Yeah. So what I show you just now in MATLAB is where I plot the graph between sepal length and sepal width for each sample or each species. So that is why you manage to get this picture, something like this, and something like this, as well as not this one. Yeah, something like this. Yeah. So if you plot the graph, petal width and petal length, you differentiate the color, you will get something like this. You can easily plot this graph in MATLAB. Okay. If you want to choose only two class, say for example versicolor and virginica, and you choose sepal width and sepal length, and you put the versicolor red, virginica blue, you are going to get this kind of plot. And if you ask them to plot the class boundary by using LDA method, you will get something like this. Okay. Are you okay, everyone? Is there any question that you like to ask for Iris dataset? If no, put number 1. Okay, I close this Excel file. All right, and I go to our folder ch4_da version 2. Okay. Now, you can open the da_ed_mzj. Yeah, you open this file. Okay. Let me try to explain what is class boundary. Okay, what is class boundary? Okay. All right. In this example, I show you the plot. Okay. I have 10 sample for blue class. Yeah. Let me try to make it bigger. Okay. I have 10 sample for blue class, and I have 10 sample for red one. Yeah. Okay. Look. The value for X is this. Yeah. Under this column. Yeah. This is the X value. This is the Y value. So where I can use this data, editing this, and then the minus. Okay. What is this? Yeah? View collaborator. Later I will explain this. What is going on this? Wait to edit. Got it. Notify events. Okay. Look. Okay. Now I plot the blue data. I plot the blue data. This one, yeah, the blue data, and I got this blue dot. Yeah, and I put the orange area. This one. That's why I managed to get sample number 11. Yeah, starting from 11 to 20. This one. Yeah, and I plot the center. This one, the center, I put AVB, the center or the average for B, and this is the center for orange. Yeah. So then I draw the line. So along this line, along this green line, the distance between the center of the data is equal. Yeah, the data for this to the distance between A B with the green and the green to AVO is the same, is equal. So along this line, we call it class boundary. Anything which is not fall into its group is going to be known as a misclassified. So if you look at here, sample number 17, is it? Okay, sample number 17 is on the blue area. Okay, 17 in the blue area, isn't it? So we call it misclassified, put 0. Okay, incorrect, 0. Yeah. The same goes to sample number 4. Okay, sample number 4 is 0 as well. Okay. Now I wrote my own MATLAB, Excel, so that you can understand. You read the code and then you can understand how we do it in Excel. Okay, this is the average of blue. This is the average for blue for Y data, X data, and the average for orange for X, average orange for Y. This 6.7 is the average for this one. Yeah, 3.8 is the average for this one. Okay, now look at the distance that I calculate. I can calculate the distance between this data to this data, which means that the distance of sample one dot to the center for blue. Okay, look at the data. Okay, so look at the value of the data. It is 3.2. What does it mean? Okay, if you look at the plot, okay, if you look at the plot here, okay, if you look at the plot, okay, look at sample number one. So I'm calculating the value that you see there is the distance between this to this. And then another one is the distance between this to this. Okay. So you see that. Okay, I put another color. I put the color green here. Okay. Okay, the distance between sample number one to average of orange, sample number one to average of B. The value that explain the distance is this one, 3.2 and 3. So because the winner average to B, sample number one, average to blue is 3.2, average to orange is 3. Okay, sample number one, average to blue is 3.2, average to green is average to orange is 2. Okay, so the winner is the blue. Okay, so that is why blue is classified as blue. Okay, so that it is labeled as the correct one. Wait, orange, but suppose EF is less, so blue, orange, yeah. Okay. Um, I have to check this value again because 3.2 and 3, so this one supposed to be orange because the winner is 2. I have to check this formula again, but this one is correct, yeah. This one is blue, this one is blue, this one is orange, this one is blue, this one is blue, yeah. Compared to this number, yeah. This one is blue, this one is blue, this one is blue, this one is blue. This one I have to check the formula again. Okay, so that how we call the winner or correctly classify is based on the distance between this data, this point to the average average distance of the class. Okay, so this is how we can calculate into by using Excel. Now, how we calculate the percentage correctly classified? Okay, look, if we manage to calculate, yeah, the distance, so it is all correct, isn't it? All correct, so that the blue is 20, isn't it? So all of the blue is correct, all of the orange is correct, so that you can look at from here the the percentage error is 0 because all is correct. Okay, let me try to explain another plot here. Okay, okay. Another sample of data here, blue classify as blue actual, yeah, so it is correct. So blue and blue correct. Okay, orange and orange correct, yeah. So this is just only an example of how you can calculate in Excel. Okay, now I want to go to MATLAB. Okay, if you go to MATLAB, the codes that you can use is under the CH_DA version 2. Okay, first, how to use MATLAB, yeah. So if you have MATLAB with you, okay, if you want to use the codes that I provide you, you must make sure that you have the path. We call this path, yeah. Okay, for example, if you want to use this, you have to download the 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 course that I provide you. So this you are going, if you put the folder here, you find the folder. Say for example, I put my folder here, one underscore chemometric UPM underscore 24. It is on my desktop like this. It is on my desktop like this. Okay, I go to my desktop. It is like this. Yeah. So that I can see all of this on my Excel. So if you couldn't find it, you can browse through this one. Yeah, you can go to this one. Okay, you can find the folder. You click, wait, you click this one. You click this one. You find the folder that you are interested in. For example, on my desktop, okay, I have this folder. Okay, I want to use which one? This one. You click and then you click select folder and you can see this. Okay, if you want to change, okay, if you want to change, you click on this one. Maybe you want to choose another folder. For example, here, maybe you can choose this one. Okay, so that you can click select folder so that you can see what is under the CH5PCADA. Okay, so this is how you can use MATLAB. Okay, so now I go back to the original file that I want to start for today. CH4_DA version 2. Okay, if you want to learn the basic, you have to go to the first file, C4_1 basic MATLAB function for classification. You click. Okay, when you click that file, you will see this output like this. Okay, now I want to make sure you understand what you are doing. Okay, so type of code in MATLAB to classify. Okay, the green one, I make it bigger. The green one is the instruction. It has nothing to do with the code, but it's just only an instruction. You can type anything you want if you want to explain. Say for example, this one, yeah. This the black one is to clear to see as it clear the data. Yeah. Okay. Now, in MATLAB, you have what we call this one to show the current folder. What is the content of your current folder? This is what we call editor. What you call editor? This is command history. Yeah, this is command history. This is your command window. Okay. If you don't get this, okay, I close this one. Yeah, I close this one. Command window is like this. If you type like in our last class, yeah, if I say for example I want to type x equal to y, yeah, so, sorry, x equal to 2, for example, yeah. So how to see the command is like this, and then the data for this is on the what we call data set. Okay, you go to layout, you go to command history with default. Okay, layout, three column, organized layout, close with three column, all command history, doc, current access, current folder, with organized layout, no, close with three column. Yeah, you have workspace here. X equal to 2, name X equal to 2. If you type Y equal to 4, you will get Y 4 like this. Okay. Workspace. This is what we call workspace, where you can see the data set that you already generated from this command window. Okay. So if you want to see what you have written, you can go to layout. You put command history doc. Okay, this is your command history. Okay, command history. This is going to be your workspace command history. Okay. Now, if you want to open this file, you double click on it. You double click on it. So MATLAB will open this. So what is the meaning of this code here? This item. Okay. So the name of the file that you open just now is this one. So that you can see the name of the file is like this. So containing numbers of script that you can run slowly one by one. Okay, let me show you how to do it. Yeah. Okay, first of all, I want to clear my screen here. CLC clear. So I want to clear my data. I type CLEAR clear. Okay. So I want to run this script. So that the first one, I type clear the data. So I select this one. I right click. I say evaluate selection clear. Okay. And the second one, line number 4. Okay, line number 4. I want to load Fisher iris, which means that I'm going to load Fisher data. So this Fisher data is already in MATLAB, so that you just can type load. Load meaning that you are going to load the data. Okay, select this one, right click, evaluate. So you see, so when you select and you right click, evaluate selection, you can see the appear of maze and species. What is maze? What is species? Maze is short form of measurement. Maze is the short form for this data. This data. Yeah. Maze is the short the label for this data from 1 to 150. You can compare, the data is the same. Okay. So what is the species? Okay, if you want to see the data, you can double click. You can double click and see this value 5.1, 3.5, 1.4, 0.2. They are exactly the same. They are exactly the same. 5.1, 3.5, 1.4, 0.2. Yeah. I go to my MATLAB. Yeah. Okay. So what is species? Species is the label for the class here. The class here. I put Setosa, Versicolor, and Virginica. So that you can, if you want to see it, you double click. Okay. You see the Setosa, Versicolor, and Virginica. Okay. Now you have the data for this. Yeah. So what you wanted to do, if you go to the script, you just want to say, you want to have X. You just want to take the data. Okay, what is the meaning of this in MATLAB? Yeah. So in MATLAB, okay, I don't want to use this now. I just want to show you a simple one. Okay, if I type MA, okay, A is equal to MAGIC, magic. Say for example, I have matrix 4. Yeah. So I have matrix 4. If I say I want to type B is equal to A, I just want to take every row, but only column number 1, I will produce only 16592. This is how we operate, or we manipulate the data in MATLAB. See, so the output is like this. Yeah, just take this one, which means that the column is going to tell you that we are going to take all of the rows and only column number 1. Okay, if look at this data, yeah, look at this data. What is the meaning of this? I just want to take column number 1 and column number 2. Okay, so that I can type B. I can type B equal to A. Okay, all rows. Yeah, all rows. If I type 1, comma 2, like this, meaning that I'm going to take only 1 and 2 here, so that the output will be the first 2 columns. Great. Yeah. Okay. Okay. 1 and 2, like this. 1 to 2. Okay. If you want to take 1 and 3, 1 and 3 only, you can use this function 1 and 2, like this. So 1 and 2. Okay. You can change to 3, which means that you're going to take only 1 and 3. Okay. So if I type A is like this. So if you type 1, 1,3, meaning that you're going to take only this and this. Okay. So this is how it works in MATLAB. It's very straightforward. Okay. So like here is, if you use this code, meaning that you're going to produce matrix X, which is coming from maze, yeah, coming from maze, and taking only column number 1 and column number 2. Okay. So what is Y? Y is going to have the same content as species. This is what it meant by this code. So if you want to run it again, okay, you just simply select everything and you just right click and evaluate selection. Okay, so now you have original matrix, MEAS, and species, and you have X only taking column number 1 and column number 2, and Y is the same as species. Okay. All right. If you want to make a prediction, okay, as I mentioned just now, how to produce a confusion matrix. This is the process of how to do classification. You have to include, okay, in MATLAB, yeah. So there is function like, say for example, you have data A, for example. I just want to give you another example. A equal to magic, yeah. A equal to magic, magic, magic 4. Yeah, I put A equal to magic 4, for example. Okay. In MATLAB, if you want to find the average, yeah. So for example, matrix B is equal to average. Average in MATLAB we call it mean, MEAN, mean. Mean, you want to find the mean of matrix A. So which means that matrix B is going to the mean of each column. Yeah. So you hit A. So the mean for each column is 8.5, 8.5. This is why we call magic. Okay. If you want to sum, okay. So the code is the function is sum of A. So you sum this column, you sum this column, you sum this column. The value is 34, 34, 34, 34. Okay. If you put another metric, for example, A is equal to RAND. Okay, this is just a script of how to generate sample data. 10, for example, 10 2, yeah, 10 2. Okay, 10 equal to 2. Maybe you want to put 10 and 10, for example. Okay, input must be scalar. Okay, I forgot to write the code. proper code for this. Okay, you forget about this at this moment. You can type any matrix if you want to, and then for example, yeah, I put A equal to magic 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 5. Okay, magic 5. If you say you want to get the sum, okay, B is equal to sum of matrix A. Okay, so they will sum all of this column, this value. So the same goes to this function. Okay, this function, we call it FTC, this DISCR. This function is built-in function in MATLAB. So what they wanted to do is you have to include the value of variables, you have to include the value of the class, and you have to specify what to discriminate. You want to discriminate by using linear classifier. Okay, so that is how you can use MATLAB to make classification, and the output is the label that you will produce, and from this label you can get the confusion matrix. Okay, if you run one by one, okay, you type clear first. Okay, no, you don't need to type clear because you're going to use this X and Y. So you select this one, you right click, evaluate. So the output is the model, and then you put label, right click, evaluate. Okay, so you put the label, and then from the label you can select this one. You say you want to evaluate. Okay, now the output, the confusion matrix is like this. Okay, here you can see just now I show you in our slide. I put two class system. Yeah, two class system. They gave you 3.8, 38, 37, 12, and 34. But for more than two classes, you can see MATLAB can do it for you as well. 49, 36, 35, which means that this one is AA, this one is BB, this one is CC. Okay, so this is how you can run and find the confusion matrix in MATLAB. Okay, so how to maybe you can, if you want to understand more about this, yeah, you can add any data for species and label. You can imagine if you have a data as what I show you just now here. Maybe you have blue classified as blue, blue classified as green. This is the original one. This is the predicted one. So you just insert this data into this function. Okay. Or if you want to, if you want me to show you another sample, yeah, I put clear, CLEAR, clear. I have X. I have X empty. I have one Y empty like this. Okay. I go to here X and X. You have class 1, class 1, class 1, class 1. Okay, class 1. Okay. This one I have class 2, class 2, class 2, class 2, class 2. Yeah. So how many? I have 5 for class 1. I have 5 for class 2. This one is for X. Okay. When it comes to prediction, I have this one class 1, predict class 1, but this one is predicted as class 2. Yeah. This one is predicted as class 1. This one is predicted as class 1. This one is class 2. Yes, predicted as class 2. This one is predicted as class 2. This one is predicted as class 2. But this one is predicted as class 1. This one is predicted as class 1. So the Y now, if you can see, the Y now is the predicted class. The original class is X. Okay. So how to use this confusion math? Yeah, you select this function. Yeah, select this function. Control C. You put it here. All right. So you put your X here. You put your X here, and you put your Y here. Okay, which means that this is the original class X. The Y is the predicted one. You hit enter. So you get the conversion metric for 3. So there are only one of A classified as B. There are two of B classified as A, as what you see just now. Okay, you understand how to use this function? Is there any question? Maybe I'm showing you a bit faster. You can ask me if you want to. You can Google, or I can provide you extra class this weekend to understand MATLAB. Okay, class, are you okay? It seems quiet. Okay. Okay, I have the data set as well. If you want to try with your own time, yeah. Like here, if you go to line number 17, yeah, go to line number 18, select, okay, clear all, evaluate. So I clear the data, and I load this data. How to load the data? The data is this one, 3A, yeah. Wait. Okay, this data. Okay, let me try to explain. If you wanted to perform classification, you have to understand the data set that you have. Okay, the data that you have containing 225 samples and 25 variables. Yeah. For classification, you can classify only by using a minimum one variables, or you have two. But this one you can do classification by using all 25 variables. So if you include y straight away, x straight away, meaning that you're going to classify the data by using all variables 25. Okay, so what is our x? X is 225 multiplied by 35. What is our y? Y is our class. Okay, let me try to show you the data. The class is this one, toxic. Yeah, toxic, and this one is moderate. Yeah, this one is non-toxic. Yeah, so there are three class situation. Okay, so I can label this data into class number. Instead of I have toxic, non-toxic, I have class 1, I have class 2, I have class 3, and this is the data for each class. Yeah, variable number 1 until variable number 25. Okay, so the data is the same as the x. Okay, so now how we can do it? Yeah, so I just give label of y equal to class evaluate, and I run the model here. I run evaluate. Yeah, the predicted of the class is labeled predicted model x. This is the function to predict evaluate. All right, so that the output conversion map is this one, evaluate. Okay, so what can you see? The result is like this: 92, 93, 47, 51. And A classified as A is 93, but A classified as B is 6. Okay, class. So this is just only a classification without saying class boundary. Okay, if you want to see the class boundary, you can try to look at this function. Okay, you double click on it. Okay, you double click. Yeah. So this is the function. So for the function, what you need to do if you want to do it, okay, you select this one, yeah. You select this one, Control C, copy. Okay. First of all, you have to clear the data, clear CLEAR, clear, and you paste the black font, yeah, the black font, not the word function, only the black font. And classifier type, you type like this. Okay, you type like this. Put the symbol like this, and you put KNN1. This is the classification in term by using the idea of KNN. Okay, I don't explain, but this is just only a method of how to classify the data to create the class boundary. Okay, I hit this one, yeah. But you have to wait. Okay, look, this is what we get. Okay, the confusion matrix from this output is 30, 30, 0, 0. So accuracy is 1, precision is 1, recall is 1, F1 score is 1. That's why I mentioned to you, you don't have to worry about how to calculate the data, the accuracy. The software can do it for you. So what can you understand is that there is none of misclassified, okay? Because the class boundary that you are using now is KNN1. Okay. Now, if you change for another one, yeah, another one, I put KNN3. I hit enter. You see now? You see? The confusion matrix is now no longer 30, 30, but now 37, 3, 4, 36. Accuracy is 0.88. Okay. So now you can see that some of the sample has been misclassified, where I put the misclassified as an X, like this. Okay. So now, if I change another, what to change actually? What to change to see the class boundary? You can change, if you look at the script, okay, you can change the label KNN1, KNN3, KNN5, SVM3, and Forest Logistic. This is one of many classifier that I mentioned in my slide just now. This one. This one. I did mention about a classifier. Wait, yeah, this one, quadratic, partially square, but I don't include some of the classifier here, but I put it here. Okay, if you go for KNN5, you want to try for KNN5, you can type KNN5. KNN5. So the output is like this for the class boundary, and the data, the result is here, 28 to 833. So you can compare the result from each classifier, which one is better, by looking at the accuracy. As someone just asking me just now, how we can measure the performance by looking at the accuracy. You can change, okay, for the same data set, you can change the classifier. If you want to know more the theory behind the classifier, which I don't include in my slide, you can go to references. You can ask AI what is KNN5 classifier, what is SVM classifier. You just train the AI to help you to understand. You are now studying classification, you want to know more. But from my point of view, it is enough for you to understand that there are a lot number of classifier. So the classifier will give you the class boundary like this. For KNN1, you're going to have something like this. For KNN2, you will get something like this. Okay, KN2 and KN1 will give you different idea of the class boundary. Look at the data set is the same, yeah. You look at the data set the same, but the way they draw the class boundary is different. So this one give you 100% correctly classified, but this one is not. Yeah. So it depends on what classifier that you are using. Okay. If I can change to another classifier, I put maybe here linear. Okay, or quadratic. Okay, look, I just want to show you the difference between linear and quadratic. I put linear. L-I-N-E-R, linear. I hit enter. Okay. This is linear class. Okay. The same data set, linear. But if I put quadratic, quadratic, Q-U-A-D-R-A-T-I-C, quadratic. Yeah. Okay. This is quadratic. This is linear. Okay. How they draw the line is based on how they calculate the distance between one class to another class. So as you can see here, they gave you different accuracy. Look at for quadratic 0.83, for linear 0.83 as well, but the accuracy is the same, but the precision is different. See, so that's why we need to have different method on how to measure the performance. Other than accuracy, we can use precision, we can use recall, we can use F1 score. If you want to know more what is precision, recall, F1 score, you can use Copilot or Gemini or ChatGPT. Okay. So today, in today's class, I'm not able to give you all of the example in my folder, but I think enough for you to try at home the meaning, or to understand the meaning of this classification by using MATLAB. Yeah. Say for example, this one I put 3 classes. Yeah, put 3 classes. Okay, I close this one, copy, I put it here, and I use KNN as well. Okay, KNN 1, class boundary. Yeah, this is an example of class boundary with 3 groups. Okay, this one. Okay, so class boundary miss. Okay, I add the function miss, M-I-S-S, miss. Yeah, no misclassified. Okay, because I use KNN1. Okay, I put KNN3. Is there any misclassification? Yes. So the one that you see in the cross one is the one that has been misclassified. Okay, so the result is there as well. It's like this. Okay, so in other words, what I wanted you to understand today is that different classifier will give you different class boundary. Okay, so that is why different class boundary will give you different confusion matrix. From confusion matrix, we can measure the accuracy, the precision. Accuracy, precision, recall, and F1 score is how we can evaluate the performance of the classifier. All right. Are you okay, class? Is there any question that you'd like to ask for today? We have 10 more minutes to go.
Doctor,
Yes.
how we know which classifier is the KN3, KN1, doctor?
How we know? How? Okay. Now, first of all, you can study what is the meaning of KNN1. Okay. When you want to choose how to classify the data, you can look at the script that I provide you. You can choose this word. Yeah. See, if I want to use KN1, KN3, meaning that they are going to use this idea. Okay. Okay. Now, if you use SVM, they are going to use this function. How they calculate is based on the theory, how they want to classify the data. Understand? So after they manage to classify, they will give you the result. What is the output? That's all I can explain to you. Okay, what is K and N? Okay, what is K and N? Uh, I think you understand linear, isn't it? Linear is how you can separate based on the distance. But for K and N, they will measure how what is it? They will measure the neighbor of the data. Okay, now look at if I choose K and N1, yeah. If I choose K and N1, okay. Normally, when you choose KNN1, you will get 100% correctly classified. Why? Because they only want to consider only one next neighbor. Okay, look at this sample. Okay, I make it bigger. Look at this sample. Yeah, wait. Um, okay, look at this sample. Look at this sample, and look at this sample. Okay. Wait. I'm not going to use blue. I'm going to use purple. Oops. Wait. Wait. Okay. Now look at this sample with this sample. Yeah. So in MATLAB we can calculate the distance between this and this. So this is the middle of between these two. So they just consider the distance between the uh, one of the opponent. Okay, this is why you can get the distance between this. The boundary is here.
Okay.
Okay, they just measure, like for example, another example. Yeah, the distance. Can you see the line here? So
Yes.
they just consider only one neighbor,
Mm.
which is opposite to it. Yeah, which is opposite to it. So this one, you see why we get this line, because they measure the distance between this and this. Okay, when you increase the neighbor, meaning that you have to find the winner, the winner, the winner. You must have uh, the number, um, the number in one, three, or five. That's why if you go for three, okay, if you go for three, so they will consider three member. So what does it mean by three member? If you look at here, they will consider three member of the opposite from this one. So that is why you find that this sample is being misclassified, because the boundary is here. Okay. So now I can help you to understand how I use AI Copilot, yeah, for this one, yeah. So you can choose Gemini or Copilot, for example. Okay, I type Copilot here. Okay, okay. How you can understand by using Copilot? Wait, where is my Copilot? Okay, explain me. Okay. Yeah. Explain me what is KNN is in classification. Yeah. Okay. Sebagai powerful algorithm used for classification and representation in machine learning. Here is background. Instant-based learning, distance metric, k-neighbor, majority voting. Yeah, majority voting. No training phase, advantage. Okay, simple to understand, implement. Okay. Give me data, sample data to understand. Okay. Okay. Apple, red color, banana, yellow, orange, yeah, lemon, yellow. Size 7, weight. Okay. Now they calculate. Okay. Calculate the distance, compute the distance between new fruit and each fruit in the data set. We'll use Euclidean distance. See, did I mention just now Euclidean distance? Yeah. So find the k nearest neighbor. Identify the three closest fruit to the new fruit based on the calculate distance. Majority voting. Okay. So let's calculate the distance between new fruit and each fruit in the data set. So distance to apple, distance to banana, distance to orange, distance to lemon, distance to grape. So you have the distance. Okay. So the three nearest neighbor are banana, lemon, and apple. Since banana and lemon are both yellow fruit, and the new fruit classified as a banana. Okay, this is how we use KNN. So I think KNN is very easy to understand. If you still don't understand, you can ask them to give you more example. So here in this class, I help you to understand how to classify the data by using MATLAB. I provide you the function, and what most important, you see the plot. Okay, you understand uh, when the sample is not good, is not in its area, is being identified as misclassified, and from the misclassification you can get the, what is it, the confusion matrix. Okay, did you find easy? Any more question? You can ask me, you can WhatsApp me if you don't understand how to use the code and the function. Okay, okay, Pavitra.
Okay, doctor.
Okay, good. Any question from the floor? You can try any codes that I provide here. Okay, if the code is with a function like this, you just copy. You just copy this one. If the code is without the function word, you can simply run one by one. For example, this one, yeah, plot boundary 11. If you click plot boundary 11, okay, you can run it one by one like this. If you don't understand, let me know. Okay, so I think that's all for today. If you don't have any question, till we meet again next week, I can offer you my help to understand what is classification in chemometrics, if you want to, by using MATLAB, so that you can easily complete your assignment. Okay, so that's all for today. Uh, good night, everyone. Bye bye.
Thank you, Doctor.
Thank you. Thank you, doctor.
Yeah, welcome.